My students, after that short break, let us proceed with our today lesson. And at this particular time, we're going to look the so-called characteristics or attributes. We can say attributes or we can say characteristics of musical sounds. Normally or generally, the musical sounds are characterized by the following characteristics. They have three. The first one is pitch. The second one is loudness, and the last one is called quality or timbre. These are the three main important characteristics of musical sounds. That means we can distinguish between one musical sound and another by looking onto their pitch, by looking onto their loudness, by looking onto their quality. This is what we mean. Now let us begin with pitch. Let us begin with pitch. When we talk about pitch, we means how quick or how slow the musical sound is. How quick and how slow the musical sound is. Therefore, we can distinguish one musical sound and another by looking how quick and how slow. This is quick, this is slow. But in physics, we are saying pitch. For you to know how quick is and how slow is, we normally look on their frequency. How quick is, how slow is, we normally look on the number of cycles completed per second. The number of cycles. How many cycles did this sound or musical sound completed in a second? That means many number of cycles in a second, we are saying this sound is quick. But slow or less number of cycles per second, we are saying this sound is slow. Therefore, pitch, we talk about frequency. Therefore, pitch is accompanied by frequency. Now let us have the waveform like this one, which illustrate about a quick sound and a slow sound. We have a baby sound waveform, which is this one. Did you see? Let us assume this is a 1 second. Here is 1 second. And here we have 1 second. Within 1 second, a baby completed Hellman cycle. 1, 2, 3. 3.5. And this one, 1 and only 2 cycles. Here is 2 cycles, but here is 3.5 cycles. This is baby sound. This is what? This is adult sound. Therefore, we are saying baby sound is a quick sound. It has high pitch because it has many number of cycles per second. This one has low pitch because it has few number of cycles per second. Therefore, when we talk about frequency, when we talk about pitch, we mean the number of cycles the musical sound completed per second. But also another thing which we must note here, we know that the distance from a crest to crest is called wavelength. But also here, the distance from crest to crest is we call wavelength. Now look, the wavelength of the baby sound and the wavelength of adult sound. When you talk about you see the wavelength is small, but when you talk about which is now the adult sound, you will see the wavelength is what? Is longer. Therefore, as quick as the sound is, as shorter as the wavelength is. As slow as the music sound is, as longer as the wavelength is. As quick as the sound is, as many number of cycles we are going to produce. As slow as the sound is, as small number of cycles we are going to produce. Therefore, pitch is characterized by frequency, but also the 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 wavelengths. This was pitch. Another factor which help us to determine one sound and another is called loudness. Loudness. When we talk about loudness, we talk about amplitude. The amplitude. How far the musical sound moves from equilibrium positions, how the vertical upward displacement from equilibrium position. Or we talk about the sound, the energy. Here we talk about energy per second. Energy per second, the ear heard per vibration. This is what we talk about loudness. How louder it is. Now we have the figure here which talks about a louder sound and a quiet or soft sound. Now when you have a high vibration, that sound when the particle vibrates high, that means that sound is called louder. Louder means amplitude is greater. But when the amplitude is small, like this one, we are saying this sound is quiet or soft. Therefore, in loudness, we normally distinguish it by considering the amplitude. For example, my sound is louder because it has high amplitude. My sound is hard because it has high amplitude. Vibrations, or because it has high energy. But someone's sound is quiet because it has low amplitude, low energy. Therefore, this is concerned about amplitude. Therefore, sometimes it could be asked to draw the wave diagram which shows that the sound which is louder but also quick. Louder, quick means it has many number of cycles, but also it has high amplitude. Louder and quick, many number of cycles per second, but also has high amplitude. That is the meaning. Lastly, characteristics is called quality or timbre. Quality, or we call it timbre. We normally say these characteristics is the characteristics of the great singers. That means if the characteristics which can distinguish two different musical sounds which are sounded at the same note. That means the two musical sounds, how can you distinguish two musical sounds sounded at the same note? For example, let us assume we have different instruments. We have a piano, which is string instrument. We're going to learn it in the next lesson. And we have flute. This is the wind instrument. These together, they have been sounded at the same frequency, 256 Hz. And this one is also sounded at the same frequency, 256 Hz. Now, how could you identify the sound, the musical sound of piano, and this is the musical sound of flute? That's why I'm saying this is the characteristics of a great singer. Because how can you identify this? They are sounded at the same frequency. But you are required to identify this is piano, although it is sounded at 256, and this is frit, although it is sounded at 256. These characteristics which help you to distinguish these two is what we call quality or timbre. Now, for you to distinguish two or more instruments sounded two or more different instruments sounded at the same note, we normally use quality. And in quality, we are not using frequency, we are not using amplitude, but we are using the so-called waveforms, or the so-called overtones. That means we are using the waveform. These two or three or more instruments they are going to produce, so as it can be easy for us to distinguish them. Otherwise, it will be very difficult. Waveforms, or when we talk about quality, we talk about waveforms or overtones. Look here. Do you see this diagram here? This is tuning fork, this is piano, and this is violin. Both of these they have sounded they have played at the same frequency. Let's say all of these they have been played at the same frequency of 256 Hz. This was also 256 Hz. This was also 256 Hz. But how can you distinguish now? How could you know this is the tuning fork, this is the sound of piano, this is the sound of violin? To distinguish this, we use quality. And in terms of quality, we are looking the waveforms. Do you see the waveform of tuning fork is different from that of piano, and that of piano is different from this is violin. Therefore, due to their waveforms, we can distinguish the sound of different music instruments sounded or played at the same note. How? Look here. These waveforms, they are instructed from the CRO, because the CRO is connected to the microphone. Therefore, near to the microphone, the tuning fork was sounded. Now, what was look on the screen was this one. Likewise to piano, what was observed on the CRO screen was this one. Likewise to violin, what was observed on the CRO screen was this one. Therefore, this is the ones which can help us to distinguish two or more instruments, different instruments, played at the same note. We normally use the so-called what? Waves. Forms are different, or their overtones are different. That question is very, very important. So at that point, those are the characteristics of music instruments. See you in the next lesson. Bye.